Hey friends, welcome back to another session. Today our topic is HCF and LCM. HCF and LCM is one of the basic of quantitative aptitudes. Hence, from class 5 to class 10 on every placement of bank, NDA, civil services and other competitive examinations always have 2 to 5 questions from HCF and LCM. The concept of HCM and LCM is also useful in other topics too, and a good command over them will not only increase your score but will save your precious time in examinations also. Today we will learn some tips and tricks to identify and solve sums related to HCF and LCM. In this video we will cover the HCF and LCM of number, HCF and LCM of decimal, HCF and LCM of fractions and HCF and LCM of exponential power. So let's begin. I am Sagar Kumar Singh, welcoming you all in my channel, The Warrior Classes. First of all, we will learn the HCF. The full form of HCF is highest common factor. It is also called as GCD. The full form of GCD is greatest common divisor. And the definition of HCF is HCF of two or more given number is the largest number which divides each of the given numbers without leaving any remainder. Let us take an example and understand it better. Let us take an example of 12 and 18. So here they have told to take out the factors. So the factors of 12 are 1 multiplied by 12, another is 2 and 6, next is 3 and 4. So these are the factors of 12. The factors are 1, 12, 2, 6, 3 and 4. Likewise the factor of 18 are 1 into 18, 2 into 9, 3 into 6. So the factors of 18 are 1, 18, 2, 9, 3 and 6. So we can write it here likewise. 12, the factors are 1, 12, 2, 6, 3 and 4. For 18 the factors are 1, 18, 2, 9, 3 and 6. So these are the factors of the numbers. These are 12 and 18. The common factors between 12 and 18 are, that is 1, next is 2, 3, 4 is not there, next is 6, here also 6. So these are the common factors of 12 and 18. The highest common factors between 12 and 18 are 6. So the highest common factor will be 6. So the HCF will be 6. So 6 is the number which is divided by 12 and 18. So this is the highest number. So the HCF will be 6. Likewise, we will understand the LCM also. The full form of LCM is lowest common multiple. It is also called as least common multiple also. Least common multiple. The definition of LCM is the least number which is exactly divisible by two or more numbers. We will take an example and understand it better. We will take the example of 4 and 6. First we will take the multiple of 4 and 6. Multiple of 4 is 4, 8, 12, 16, 20, 24, 28 and so on. Likewise, the multiple of 6 is 6, 12, 18, 24, 30, 36 and so on. Now which are the common of the 4 and 6 of multiple? The common are 12, here also 12. The common multiple are 12, next is 24. Likewise, it will become 36 and so on. For taking out LCM, we will have to take the least number. The least between the 12, 24 and 36 is 12. So the LCM will become 12. The LCM of 4 and 6 is 12. 12 is the number which is divisible by 4 and 6 both. Now, which are the methods to take out the HCF and LCM? There are two methods to take out the LCM and HCF. One is prime factorization method, another is divisible method. First of all, we'll look into the prime factorization method. We'll take example and understand it. We will take an example of 12 and 18 here also. The prime factors. Which are the prime factors of 12? The prime factors of 12 are 2 into 2 into 3. If we will multiply 2, 2 and 3, it will become 12. And likewise, for 18, it is 2 multiplied by 3 multiplied by 3. So, which are the common between 12 and 18? These are 2, here also 2 and 3 and 3. So, the HCF is common between both of them are HCF. So, the HCF will become 2 multiplied by 3, that is 6. Now, LCM. For LCM, list of common prime factors multiplied by uncommon prime factors. The common prime factors are 2 and 3. We will write 2 and 3, and the uncommon prime factors here is again 2 and here also 3. 2 and 3. We will multiply it by 2 and 3. This will become the LCM of 12 and 18. This will become, if we will multiply 2 3 is 6, 6 2 is 12, 12 3 is 36. So the LCM of 12 and 18 is 36. These are the method to take out the LCM and HCF of numbers. And the next is division method. To take out the HCF by division method, we will take example of 54 and 90 by division method. We will divide the larger number by the smaller number. The smaller number is 54, the larger number is 90. We will divide it here. Now it is one time. We will write here 54. If we will subtract it, it will become 6, 8, 5, 3. Now the remainder we will take as divider and the divisor as dividend. This will write like 54 and we will do it again here. One time it will become 36. Now we will subtract 14, 6, 8, 4, 3, 1, and now we will divide it by 36. We will write 36 here. 18 2 is 36. Now the remainder is 0. So the divider, that is 18, is the HCF of the numbers. The HCF is 18. This is the method to take out the HCM by division method. These are the method to take out the HCF and LCMs. We will take out HCF and LCM by factorization method. Let us take an example of 12, 15 and 24. We will take out the HCF and LCM of 12, 15 and 24. For this is the common method to take out the HCF and LCM. We will write it like this, and we will divide all the numbers which is common to divide the numbers. The common number which is divided by 12, 15 and 24 is not 2, because 15 is not divided by 2. So we will take the next number. The next number is 3. 3 is completely divided by 12, 15 and 24. We will write 3 here and we will divide now. For 12 it will become 4, 5 3s are 15, and 8 3s are 24. Now the next number which is divided by 5, 4 and 8, there is no number which will be completely divided by 4, 5 and 8. So the HCF of 12, 15 and 24 will become 3. HCF is 3 because 3 is the only number which is divided by 12, 15 and 24. So the HCM will become 24, and we will continue divide by any number till we get the 1 in the last. So we will now divide it by next number by 2. So we will write here, it will become 2. 5 is not divided by 2, so we will write 5 as it is, and 8, 4, here again by 2, this is 1, 5, 2. Now we'll take 5 here, this is 1, 1 and 2. We will write 2 here, this is 1, 1 and 1. Now the remainders becomes 1, 1, 1. So we will multiply it and we will take out the LCM of this 12, 15 and 24. The LCM will become, LCM is 3 into 2 into 2 into 5 into 2. Now we will multiply 3 into 6, 12, 12 5 is 60, 62 is 120. 120 is the LCM of 12, 15 and 24. This is the prime method to take out the HCF and LCM of any numbers. So we will do the sums according to this method only. Now we will solve some questions and understand the chapter better. Here the questions is, find out HCF and LCM of 84, 90 and 120. We will first write it like this: 84, 90 and 120. First of all, we will take any number which will completely divide all the three numbers. The numbers is 2. If we will divide it by 2, it will become 42, 90, 45, and this is 62 is 120. So again the next number is not 2 because 5 is not completely divided by 2. The next number is 3 because 3 is completely divided by 42, 45 and 60. It is 14 3s are 42, 15 3s are 45 and 20. So is there any number which will be completely divided by 14, 15 and 20? 2 is not there, 3 is not, 14 is not there. So there is no other number which is completely divided by 14, 15 and 20. So the HCF of this number is 2 and 3. Multiplication of 2 and 3. The HCF 2 multiplied by 3, that is 6. 6 is the number which is completely divided by 84, 90 and 120. You can check it also. Now for takeout LCM, we will continue the division. It will be divided by 2, 14 and 20. The number will become 7, 15 and 10. So next number is 5. 5 is divided by 15 and 10. We will write 5 here. 7 as it is. It is 5 3s are 15, 5 2s are 10. Now the LCM, we will multiply all the numbers and will become the LCM of this 84, 90 and 120. 2 multiplied by 3 multiplied by 2 multiplied by 5 multiplied by 7, 3 and 2. Now we will multiply 2 3s are 6, 6 7s are 42, 42 5s are 210, 210 and 2s are 420, 420 3s are 1260, 1262s are 2520, 2520. This is the LCM of 84, 90 and 120. So friends, this is the very easy method to take out the HCF and LCM of any number. Now we'll look into the method to take out the LCM and HCF of decimal. Now here the example of, now we'll take out the HCF and LCM of decimal. The decimals are 0.6, 4.8 and 36. First of all, we will write 0.6, next is 4.8 and the next is 0.36. First of all, we will count the numbers after the decimal. The maximum numbers after the decimal is 2, that is 3 and 6. Here 2, we will make it also here. If we will put 0, the numbers will not change and the value will be as it is. Here there is 1 only, we will put 0 also. Now we will not write the decimal, we will write the simple form of it. It will become 60, it is 480 and 0.36 as 36. Now this becomes some numbers. We know the procedures to take out the HCF and LCM of the numbers. Now we'll write like this and we'll divide by the any numbers which is divided by all three of them. If we look at here, the 60 is divisible by 6 and 480 also and 36 also. We'll write directly at 6. This will become 10 and 8 6 are 48, 80 and 6 6 are 36. So the next number which is divisible by 10, 80 and 6, that is 2. This will become 5, 40 and 3. Is there any number which is divisible by 5, 40 and 3? There is no number which is completely divisible by 5, 40 and 3. So the HCF of this number will become 6 multiplied by 2. The HCF will become 6 multiplied by 2. This will become 12. If you want to check, you can divide all the numbers. These are 60, 480 and 36 by 12. It will be completely divided by 12. But it is given in the decimal format. We have taken the two numbers before the decimal. So we will write it like 0.12. We will put point here. It will become 0.12 or decimal 12. This is the actual HCF of these numbers. Now we will take out the LCM. Now we will also divide it. We will divide it by 5. It will become 1. 5 8 is 40 and 3. The LCM will become, LCM of these numbers are 6 multiplied by 2 multiplied by 5 multiplied by 8 and 3. If we will multiply, it will become 6 2 is 12, 12 5 is 60, 65 is 480, 483 is 1440. For taking out the LCM of decimal, we will put the decimal where it was. It was maximum number of 2. So from right hand side, we will count 2 positions, that is here. The LCM will become 14.40. Become 14.40 is the LCM of 0.6, 4.8 and 0.36. So friends, this is the method to take out the LCF and LCM of decimal. We will take another example of 0.02, 0.04 and 0.008. So we will take out the HCF and LCM of these numbers. We will first convert the decimal into number. Here the number after decimal is 0 and 2, that is 2. Here also 0 and 4, that is 2. Here 0, 0 and 8, there is 3. We will make 3 here also. we will put 0 here, 0.02 and 0, 0.04 and 0, 0.008. So we have made 3 digits after the decimal. So we will write here all. This becomes, if we will take out the decimal, this will become 20, this is 40, and this is 8. Now we will divide it by common number. The common number here is 4. So it will become 10 and 2. Now there is no other number which is completely divided by 5, 10 and 2. So the HCF will become, HCF is 4. Now for decimal, there is 3 digits before the, now there is 3 digit after the decimal. So we will put 20 and decimal here. The HCF is 0.004. Now for LCM, we will keep on dividing. This is 5 here. This will become 1, 2 and 2. Again by 2. This is 1, 1 and 1. Now the LCM. Now the LCM is 4 multiplied by 5 multiplied by 2. This 5 4 is 20, 22 is 40. So take out the LCM of this decimal. There is 3 digits after the decimal. So we'll put 0 here and put the decimal, and this is 0.04. 0.04 is the LCM of this all numbers. So friend, these are the method to take out the HCF and LCM of decimal. So friend, for taking out the HCF of fraction is the formula of this is the HCF of numerator divided by the LCM of denominator. So here in the questions they have given the HCF of fractions. For HCF of fractions, we will take out the HCF of the numerator. Here the numerator are 16, 24 and 36. We will take out HCF of it. For taking out HCF, we will continue the method. We will take the number by which these all numbers are divisible. Here if we will take 4, 4 4 ja 16, 4 6 ja 24, 4 9 ja 36. So now 4, 6 and 9. Is there any number which is exactly divisible by 4, 6 and 9? There is no numbers which is exactly divisible by 4, 6 and 9. So the HCF of it will become, HCF of numerator is 4. HCF of numerator is 4. Now we will take out the LCM of denominator. The denominator are 5, 15 and 25. So friend, we will take out the LCM of it. For taking out LCM, we will continue this method only. 5, 1, 3 and 5. Now the LCM of it is 5 multiplied by 3 multiplied by 5. This is 5 3 is 15, 15 5 is 75. So here the HCF of it is 4. HCF of numerator is 4 and LCM of denominator is 75. So the HCF of whole number will become, HCF of whole fraction will become HCF of numerator, HCF of numerator is 4 and the LCM of denominator is 75. So friend, this is the formula to take out the HCF of fractions. The formula is HCF of numerator divided by LCM of denominator. Now we'll look into the LCM of fraction. The formula to take out the fraction of LCM is the LCM of numerator divided by HCF of denominator. Here in the questions, take out the LCM of these fractions. For taking out LCM, we will first take out the LCM of numerator. The LCM of numerator are 8, 12 and 32. We will continue this method to take out the LCM. We'll divide it by 4 because by 4 the whole number are divisible. For 8 it will become 2, for 12 3 and 8 4 ja 32. Now again we will divide it by 2. It will become 1. We will take 3 as it is and 4. Now we will take out the LCM. LCM of it will become 4 multiplied by 2 multiplied by 3 multiplied by 4. 4 2 is 8, 8 3 is 24, 24 4 is 96. Now the LCM of numerator is 96. Now we will take out the HCF of denominator. HCF of denominator. In the denominator we are here 21, 35 and 7. If we will look at here 21, 35 and 7, the least number is 7. By 7 this whole number is divisible, so the HCF of this number will become 7. So the HCF is 7. Now for taking out the LCM of these fractions, LCM of this fraction is the LCM of numerator, that is 96, and the HCF of denominator is 7. So the answer of is 96 divided by 7. So friends, this is the method to take out the HCF and LCM of fractions. HCF and LCM of exponents. HCF and LCM of exponents. Here the exponents are 2 to the power 3 into 3 to the power 6, 5 to the power 8, and next is 2 to the power 4, 3 to the power 5, 7 to the power 4. Now friend, we will take out the HCF of these exponents. All three exponents. For HCF, we will first take out the common numbers. For HCF, we will take the common number which is available in all three parts. Here, if we look, 2 is available here, and 2 is also, and 2 is also here. So we will write 2. For now, the power of 2, which is the smallest power, available in these three parts. Here the 2's power is 3, here 4, and here 6. So the minimum power here is 3. So we will write 3 here. Now we will take another common number which is available in the three parts. So 3 is available here, 3 is also available here, and 3 is also here. So we will write multiplied by 3. Now we will take the smallest power between these numbers. The smallest power in these three, here is 6, and next here is 5, and here is 3. So 3 is the smallest power. Now we will write 3. Now friend, we will look into, is there any number which is available in these three parts? 5 is not available here, 5 is available here. Because 5 is not available here, we will not write 5. Next is 7 is not available here, and 7 is also not available here, so we will not write 7. So the HCF is 2 to the power 3 multiplied by 3 to the power. Here you will not have to solve these exponents. This is the answer of these questions. So in the examination also you will not have to solve these exponents. Now we'll take out the LCM of this exponent. LCM of this exponent. For LCM we will first write which is common between these all numbers. Here 2 is common, 2 is common, and 2 is common. We will write 2. For LCM we will write the maximum power. Here the power is 3, here the power is 4, and here the power of 6. So we will write 6. 6 is maximum. Now after that 3 we will write 3. Now the power of 3 is 6, 5 and 3. Here 6 is maximum, so we will write 6 here. Next is 5. 5 is not available here, 5 is not available here, and 5 is available here. So for LCM, if that is not common in all these numbers, we will write that number also. So 5 is available here, we will write 5 here. So we will write the maximum power. Here the power of 5 is 8, here the power of 5 is 4. We will write the power of maximum, that is 8. Now after that, here is 7 is left. We will write 7, and here only one part of 7. So we will write the 7 power of 4. So friend, this is our LCM. So friend, this is the method to take out the HCF and LCM of exponents. How my video is, please write in the comment section in the comment box. Thank you. Jai Hind, Jai Bharat.